Okay, students, mod 3 now. Last time I went over, in the last one, I went over the formula sheet and how you could understand it, what it was calculating. Now I'm going to do examples. So we have lateral area. LA is lateral area. Lateral means side, so it does not include the base or bases, because there could be one base if it's a cone or pyramid, or two bases if it's a prism or cylinder. Surface area, SA, is the lateral area plus either a single base or two bases, depending if it's a pyramid or cone again, or prism or cylinder. Volume, this is what the DCAS focuses on in this module. So I usually do mod 3 last because there's the least amount on it on the DCAS. This year in the first semester 404, I spent a lot longer on it. We did a lateral area, surface area, and volume. Probably for now on, I'll just focus on the volume, so that's the only part that's on the DCAS. Lateral area and surface area, they expect you already know from middle school. It's taught in 8th grade math. If the formula is an area formula, which means it's got only a degree 2 in any one of the terms that we talked about in the last one, then the units are squared, such as U squared or inches squared, meters squared, feet squared, and you pronounce it square feet. If the formula is a volume formula, degree 3 means 3 variables, or a total of 3 exponents on the variables. Then the units are cubic units. Okay, now before I get into the examples, I made an error on one of the dilations of lines in the end of the last video, so I wanted to correct that. So again, if I have y equals 2x plus 3, so that line right there. Okay. And I want to dilate it by 2 at the origin. I didn't mess up on this one, on the other one. I'm just doing it again, doing a similar one again. The thing that is preserved with dilations of lines is parallelism is one of the things that's preserved with dilations. Okay, so therefore, this is my parallel, my slope, so that's not going to change. Stays the same. It's the y-intercept that you multiply. So 2 times 3 is 6. So here's how you think of it. From 0 to 3, that's 1. So every 3 I go, that's another one. There's another 3. There's another one. So it's 1 plus 1 is 2. So that'd be double. And then going up, up to right 1. Okay. And it ends up being parallel. Okay. So that one I did correctly. So the one I messed up on is if, for example, it was y equals negative x plus 2 dilation of 2 from 0, 1. So this time it's not from the origin. So I graph the line. Start at y-intercept of 2, go down 1, right 1. Okay, so there's that line. Okay, I can adjust it right there. Okay, so there's that line. And it says the center of dilation now is at 1. Well, now remember, from here to here is 1, and I want a dilation of 2. I go 1 more. That's a dilation of 2. So that means it's twice as far from the center of dilation. So this was only 1 unit away from the center of dilation originally. Now I go twice as far, which is 2 units away. And then I have my line from there. Okay, so the new line's equation again is parallel always. So it is y equals negative x plus 3. Okay, so that's with dilations of lines. Okay, we did not get to it this first semester here in 404 because again I spent too much time on 3 and then we lost a week for the semester as well, otherwise I would have gotten to it. So second semester I'll be going 5, 4, 3 just as I have in the past to make sure I cover the main sections first. And 3 will be last, what we're doing right here. Okay, so now let's go ahead and look at problems from this. So I'm going to go through and I'm going to do surface area and lateral area, and then the volume, and then lastly cross sections. So if in your semester we did not do lateral area and surface area, you can skip through these ones and get down to the volume ones, and then the last piece of cross sections, and then you'll have module 3 covered. Okay, so find the surface area. Or surface area equals the lateral area, which is the side area, plus, since this is a prism, it's got two bases. Capital B stands for area of the base. Now in a prism, the lateral areas are all rectangles. Okay? So, one thing I need to recognize here is if that's 3 right there, as it says there, and this is 3 right here, okay, then that's a right angle, then I know it's a 45 because it's an isosceles right triangle then. That makes this 3 root 2. Okay, so when I'm doing the lateral area, this base is 3 root 2, and all the heights are 10. Remember, area of a rectangle is base times the height. So I have 3 times 10 is 30, 3 times 10 is 30 for the back two, so it's 30 plus 30 plus 30 root 2. 3 root 2 times 10 is 30 root 2. This is the lateral area. Then I add on the area of the base, and I'm going to double it. So I have 2 times the area of the base. The area of the base is a triangle. So remember, a prism is a shape that is stacked upon itself. So what shape is being stacked here? The triangle here is being stacked. That isosceles right triangle is being stacked 10 inches high. So the base is what's being stacked. Whatever shape is being stacked is the base. So it's a rectangle. Remember, area of a rectangle is 1/2 base times the height. And don't forget, base and height are always at 90-degree angles. They touch each other. So therefore, base and height, or vice versa. Remember, across from the 90-degree angle is the hypotenuse. The hypotenuse is never, well, um, actually it could be, but base and height are across from each other. Or not across, base and height are perpendicular to one another. So we have 3 and 3. 1/2 base times the height. 3 times 3 is 9. Half of 9 is 4.5. So that's the area of one base. And I double that. I have 2 bases up. The other base is up here. And then I found the surface area. So I doubled that. So I have 9 right here. Plus this right here. So I have 60 plus 9 is 69 plus 30 root 2. And since it's area, it's units squared, and the units are square inches. So there's the surface area. That's the exact surface area. Now, usually on these sheets, I'll say round to the nearest tenth. So then I'd plug that in the calculator. So I bring up my calculator. I have 69 plus 30 root 2. Hit the right arrow to get outside of that. Add it, I get 111.4. Okay, so approximately equal to 111.4 square inches. All right, next we have a cylinder. Surface area of cylinder. Again, same idea, lateral area plus 2 times the area of the base, that's general. What's the lateral area? Lateral area of a cylinder is 2 pi r h. And we have 2 bases, so it's going to be times 2. And what's the area of a base? Area of a circle is pi r squared. Okay, so there's the whole surface area formula itself then. This is the lateral area, and this is the two bases. So we have all the information we need. We just fill it in. Plug in R2 right there and there, and height 10 right there. I want you always writing down the formula first, and then right underneath it, plug in the numbers. So surface area equals, plug in the numbers, 2 pi, R is 2, H is 10, plus 2 pi, R is 2 squared. So I have 40 pi plus 4 times 2 is 8 pi, and that gives me 48 pi square meters. Again, it's area, so it's square meters. I know it's area because the formula, when I look at the formula, that's degree 2, and this is degree 2. Okay, so it's degree 2, which is area. So this is the exact answer. It's called the exact answer when I leave pi in the answer. If I want an approximate answer, now I'd put pi in the calculator. 48 pi, 48 pi, 150.8. Okay, if I rounded to nearest tenth. Oops, meters. Okay, that'd be the approximate answer. All right, last type is if it's telling me to take this rectangle and rotate it about either the x or y axis. If I rotate it about the y axis, for example, that becomes a cylinder. And so we want the surface area of the cylinder. Well, we just did it right here with this formula. 2 pi RH plus 2 pi r squared. Okay, and I'm rotating it about the y-axis, so it's coming around like this. Okay, so then from here to here would be considered the radius, and this would be the height. So it depends which axis. So if I rotate about the x-axis, the height will be where the radius is, and the radius will be where the height is. Okay, it was rotated about the x-axis, so you do have to pay attention to which axis it's rotated about. By the way, this is something like a calculus question. You'll do something like this with calculus, with integrals. Okay, it's for the end of calculus. All right, so we have 2 pi, the r is 3, and the h is 4. And I have 2 pi, r is 3 squared. So 24 pi here, plus 9 times 2 is 18 pi, which equals 42 pi in its area units squared. There's my exact answer. All right, next problems. Surface area of pyramids and cones. Okay. For the cone, surface area, again, remember it's lateral area plus, in this case, one base. Lateral area is pi RL, and L stands for slant height. Which is different from height, where height and base are perpendicular. So there's my perpendicular. So this is the base down here. This is the actual height. This from the vertex down to this is called the slant height. That's the slant height. So we have to find that. Area of the base, pi r squared. Okay. Now, notice I have a right triangle here. So I should be asking myself, do I recognize this as a Pythagorean triple to save my time? Well, remember, some that's 12, 16. But if I sit there and go ahead and look at the GCF of 12 and 16 as 4, so I divide each by 4, I would have a 3, 4, and now 5 Pythagorean triple. And so how do I get from 3 back up to 12? I multiply by 4. So this one's only multiply by 4. So the slant height is 20 centimeters. Much simpler than doing Pythagorean theorem. Okay, use your brain. Okay. So now I have all the information I need filled in. Pi r is 12, slant height 20, plus pi r squared, pi r squared. So I have 240 pi plus 144 pi. Add that together and I get 384 pi in centimeters squared. There's the exact answer. Again, if I want the approximate answer, I just plug in the calculator. Okay. Surface area of a pyramid. That would be the, again, surface area is lateral area plus area of one base. This is a square pyramid. If they only give you one length, such as 9, that means they're all 9. Okay, if they only give you one, then that means they all have to be the same as a square pyramid. And you get more specific to right square pyramid. I mean, it comes right down in the middle of the base. That's the center of the base right there. Okay, so that's called a right square pyramid, name-wise. All right, so lateral area. On a pyramid, they're all triangles. Okay, and notice they give me the height. So remember, that's 9. There is, they give me the height. That's my 90 degrees right there. That's the altitude of that triangle there. So it's 1/2 base times the height. So 1/2 of the height would be 12 times the base, 9. That's one of them. And how many triangles do I have? 4 of those. So there right there is the lateral area. Half of 12 is 6 times 9 is 54 times 4. So 54 times 4 is 216. So 216 for the lateral area. And then I add on the area of the base. And the area of a square is side squared. So it's 9 squared, which is 81. So now I add 81 to that. And I get 297 equals the surface area. And it'll be units squared, so it's meters squared. Okay. Like I said, I'm going to just do exact areas. And that means leave pi in the answer. If they want an approximate answer, then you plug pi in the calculator. Okay, next, volumes of prisms and cylinders. So remember, if it's a prism, it's got two and cylinders got 2 bases. Okay, for prisms and cylinders, that's why they're grouped together. And remember, a prism is what figuring out what shape is being stacked up. Well, in here we have this triangle that's being stacked all the way to right there. So that means this is the height. 18 is the height of it, and here's my base. That's 7, and that's 35. So the volume, okay, of a prism, volume of a prism is area of the base times the height. Now you say, oh, I only see 2 variables there. Well, don't forget area of the base. Area means it's already got degree 2 there. And there's the degree 1 for a total of 3. So it really is 3. Okay, because it really, if you want to break it down to see that, the area of the base, which is a triangle, is 1/2 lowercase b times h. So there's my 2 variables there, plus another one for 3 for volume. Okay, just so you can see that. It's always going to be 3 total variables or sides that you're multiplying to find volume. Okay, so area of the base, 1/2 base times the height, 1/2 of 7 times 35. That's area of the base. So there's my capital B times the height of 18. Okay, so half of 18 is 9. I have 9 times 7 is 63 times 35, real quick, 15, 31 and 9 is 40, 18 and 4 is 22. Let's see, 63 times 35. 2205, I was right. checking. Okay. So, and then it's cubic units. This is volume, millimeters cubed. Okay, there's my volume. All right, here's one I have to do a little thinking. I have a volume of cylinder. Remember, it's the same thing. Area of the base times the height. Area of the base is a circle, so pi r squared times the height. But that's for the full cylinder. What percentage or what fraction of the percent of the whole do I have? That's 90 degrees. It's cut out. So that's 1/4. Remember, it's 360 degrees for a circle. 90 over 360 is 1/4. So I took out 1/4. So I actually have 3/4 left. So I'm going to do 3/4 of pi r squared, h. So 3/4 pi r squared, I'm just going to put that in right now, r squared is 25, times the h, 10. Okay, so now that counts down to 2 there, and a 5 right there. 5 times 25 is 125. 125 times 3 is 375 pi over 2. And then cubic feet is the exact answer for the volume. Okay, I could just put that in the calculator as well. I'm just practicing mental math skills. All right, next. Volumes of pyramids and cones. Whenever you have a pyramid or cone, you want to think 1/3. It's 1/3 of the prism or 1/3 of the cylinder. So I'd be able to get 3 cones into one cylinder, or 3 pyramids into one prism of the same shape and height. So it's 1/3 area of the base times the height. Okay, for both of these. So for volume. Okay, so volume equals 1/3 area of the base. Again, you see it's a square, so S squared is 36, because that's 6 squared, times the height. They give me the height right there of 4. Well, 3 cancels with 36 12 times. 12 times 4 is 48. So it's 48 cubic centimeters. Okay, over here, volume 1/3 area of the base times the height again, which equals 1/3 area of the base. Now notice the 5 is the diameter. It's 1/3 pi r squared h. So I need to divide this by 2 and get 2.5. Okay, and then my height is right there, because again, I see the 90-degree angle. Remember, base and height are perpendicular to one another. So now I have 1/3 pi r squared. 2.5 squared is 6.25 times the height, 15. What, 3 would cancel the 15 5 times. Okay, 5 times 6 is 30, and 5 times 0.15 is 1.25, so it'd be 31.25 pi, and then it's cubic inches. Again, you can plug that in a calculator to verify it. Okay. Oh, and here it says go to the nearest cubic inch. So I gotta go back and read the directions. So now I'm plugging this in the calculator. 31.25 pi. 31.25 times pi. 98.2, and we got the nearest cubic one, so it's 98. So 98 cubic inches. Okay. All right, next, surface area of and volume of spheres. Okay, so one thing you want to remember about a sphere, there is no lateral area. They just have a surface area. Okay. So surface area formula is 4 pi r squared. Now, don't forget, you will be given or allowed to use your formula sheet that I gave you right here on the final. Okay. Remember, here's the formulas. I went through this at the end of the last video and explained how you got those. And then on the back side, those were hints. And the back side were the answers to each of those on the front side. Okay. So as long as you can name the shape correctly, you can find the formula right there and you plug it in. Okay, and that is just so you know, on the DCAS. So this is what the DCAS is going to look at the end of the year. You have this calculator, and off to the right, right over here where it says exhibits, this is your formula sheet. This is what everybody gets for Algebra 1 and Geometry and Algebra 2. So notice, here's the geometry formulas. Here's your cylinder. So notice it's all this volume here. Okay. For circles, we have circumference and area they give you, parallelogram, and triangle. Okay. But notice there's no lateral area and surface area. It's not being tested because it's considered 8th grade math. So here's all your volume formulas. You just have to know what the shape is. So you don't have to have those memorized for the DCAS. They're right there. Okay. Is that going to close out? There we go. Okay, so 4 pi r squared. Again, when 6 points to the center, that means that's the diameter. We need the radius, so the radius is half of it, 3 feet. So I have 4 pi 3 squared. 3 squared is 9 times 4 is 36 pi. And then area, so that's squared. Again, I can see it should be squared because I got r times r is r squared, so that's degree 2. Or pi is not a variable. So this is the exact answer. And then if I wanted, the nearest whole number, I'd plug 36 pi in and round to the nearest whole number, or nearest tenth if it asked me that. Okay, find the volume in terms of pi. Whenever you see the words in the phrase in terms of pi, that means pi must be in the answer. It's another way of just saying find. So they used to never say in terms of pi. This is how they had to break it down because so many people not understanding what exact answer means. Exact answer means you'll leave it in pi. But because kids kept blowing that, they just had to break down what exact answer means, and they told you it means in terms of pi. Okay, so that's why you see that now. In my day, it always just said it give the exact answer. Okay, so volume of a sphere is 4/3 pi r cubed. Remember, it's got to be a total of degree 3 if it's volume, and there's your r cubed. Find the volume of the sphere in terms of pi with the given surface area. So this 900 pi square inches is surface area. Now, even if they didn't tell me the surface area, how could I get that? How could I know that it must be surface area? Well, I told you there's no lateral area. And I look at my exponent here, squared, that tells me it's area. So the only area piece there is with a sphere is surface area. So that's another way you could have seen that. So this means 4 pi r squared equals 900 pi. Surface area equals 4 pi r squared. Okay, so now I need to solve this for the r. So the pi's cancel out. I divide by 4 on each side. And so I have r squared equals 225. Then I take the square root of each side. And so r equals 15 if you have your Pythagorean triples memorized. And it'd be inches down to degree 1. Now I take that 15 and plug it into right there. Okay, and it wants it in terms of pi, so pi stays in the answer. So volume equals 4/3. I'm going to leave pi at the end. R cubed will be 15 cubed. Okay. All right. So watch me do this without a calculator. I would write 4/3 times 15 times 15 times 15. You can put it all over 1 if you want. Pi. 3 cancel the 15 5 times. I know 15 squared is 225. 225 times 4 is 900. 900 times 5 is 4,500 pi. And then it's volume, so it's inches cubed. And let's go ahead and check that my 4,500 is correct. 4/3 times 15 cubed. 4/3 times 15 cubed is 4,500. There you go. Okay, next one. Areas and volumes of similar solids. Okay. Are the two figures similar? If they're similar, remember similar means same shape but not necessarily the same size. So the angle measure would be the same and the sides have to be of the same ratio. So notice the height is 15 to 6. 15 to 6. The side length is 10 to 4. They equal each other. I can I could either just reduce this each side down or I could just cross multiply right away and I get 60 equals 60. So the answer is yes, they are similar. So yes for similar. And then it says, if so, give the scale factor of the first figure to the second figure. So what's the ratio? And it tells me the order. It must go first figure, 2. Another word for 2 is colon. Second. So the first was 10. I could use either one, 10 to 4 or 15 to 6. Any pair of corresponding sides. And then I must reduce it down. So I divide each by 2 and I get 5 to 2. So the ratio is 5 to 2. Ratio or scale factor. Scale factor and ratio are the same thing. But they start using scale factor more now, so just know that. So it's 5 to 2. How about here? Well, that's easy to see. The sides are all 3 to 5. The ratio or scale factor is 3 to 5. First figure, second. I have to go in that order. 3 to 5 is my ratio. Okay. So I was just talking about scale factor. So by the way, scale factor. If they ask about the scale factor, uh, scale factor, that could be the ratio. They could give you the perimeter. Perimeter is degree 1. It's all degree 1 stuff. So degree 1, it could be side length, as we just did right there. Okay. Or they could talk about the heights. Heights of each other. Okay, so I did the heights. No, I did the side length. I did 10 to 4. I cut it down the heights, 15 to 6. All those are linear, meaning degree 1. So scale factor, if they gave me 2 heights, then I would just compare the heights. If they gave me 2 side lengths, compare 2 side lengths. If they gave me the perimeter of each, and then reduce the fraction down. Okay. All right. So that's just a side note there. The surface areas of the 2 similar figures are given. So they're telling me they're similar figures. Surface area is degree 2. Area times, every time I say area is degree 2. Okay, the volume of the larger figure is given. Find the volume of the smaller. Well, volume we know is degree 3. So I need to get up to degree 3. Well, I want to go down to degree 1 first, and then I'll cube it to get up to degree 3. So of the smaller one, I'll call smaller and larger. Okay, I take the square root of 36, and I get 6 meters for the smaller one, and the square root of 225 is 15 for the larger one. That's degree 1. Now I cube each of those. 6 cubed is 216. Okay, and don't forget that's the smaller one. And 15 cubed, put that in the calculator. 15 cubed is 3375. 3375. That's the larger one. And they gave me the volume of the larger one was 750. I want to find the smaller volume of the smaller one, X. Okay. So now I just go ahead and cross multiply. So I have 3375x equals 216 times 750. Now I just put in the calculator. 216 times 750 divided by 3375. 48. So x equals 48. So it'll be 48 cubic meters. Don't forget units or you lose a point. Okay, so what I do, I went down to degree 1 and then up to the degree that I needed, which is volume, which is cubed. So I cubed each of those. That gave me the 216 and the 3375. Whenever you're talking about ratios or comparing them like that, you're always setting up a proportion. Remember, a ratio that equals a ratio is a proportion. And you'll have 3 of the 4, and you solve for the 4th. All right, so that we went from area to volume. Now we're going to go from volume down to area. Okay, notice they give me the 2 volumes and then give me an area. So it's a reverse direction. Again, I'm going to go down to degree 1. So how to go from cubic down to degree 1? I take the cube root. The cube root. Cube root of 125 is 5. Cube root of 216 is 6. So that's degree 1. Okay, degree 1. Now I want to go up to degree 2 though, because I want to talk about area. So 5 squared is 25, 6 squared is 36, and let's see, find the surface area of the larger. So that means the smaller is 200, and we want the larger. I can cross multiply, or I could ask myself how many times is 25 going to 200, and that's 8 times. So that means I multiply this by 8, and there's my answer. So 36 times 8, that'd be 240 plus 48 is 288. And it's square inches because we're talking about area. Okay, there's that. All right, next, where'd that go? Did I skip one? What happened? It didn't save it? Hmm. It didn't save it, huh? Okay, I'm gonna have to pull it up here. Okay, so now we're gonna find the volume rectangular box, also called a prism. And this really is just Algebra 1 skills, but a lot of people struggle still with their Algebra 1 skills, multiplying binomials together. We know volume equals length times width times height. So I just multiply each of these 3 sides together. I can only multiply 2 at a time. So if I take this one and this one, I would have 2a plus 8 and times 3a plus 8. Notice I wrote it in standard form, meaning highest degree down, because then when I go ahead and multiply these, they'll line up like terms. And then I use the vertical method like you do in elementary school. 8 times 8 is 64. That's a positive 64. And I go 8 times 2a is 16a. That's positive. Then I go 3a times 8. That's 24a. Line up like terms. And then lastly, 2a times 3a is 6a squared. Let's add straight down. 6a squared plus 40a plus 64. So that's 2 of them. Now I have to take that answer and multiply by the third side. 3a plus 3. 3 times 64 is 192, positive 192. 3 times 40a is 120a. 3 times 6a squared is, that's plus 120a, put the sign with it. 3 times 6 is 18a squared. Then I go ahead and do the second row. 3a times 64 is 192a. 3 times 40a is 120a squared. And 3a times 6a squared is 18a cubed. And then I just go ahead and add straight down for my final answer. 18a cubed plus 138a squared plus 312a plus 192. All that in parentheses, cubic units, because it's volume. Okay, some people do it with the box method, and that's fine. I just never do that. I do vertical method. Okay, and last one. Finding the volume of this oblique cone. Remember, oblique means that it's slant. It's not vertical or horizontal. We don't call it diagonal, because remember, a diagonal is when I connect two vertices that are not already connected in a polygon. So that's a diagonal, and that is a diagonal. That's what a diagonal is in geometry. So we don't call it diagonal, it's oblique. Okay, well, we know the volume of a cone is 1/3 area of the base times the height. 1/3, what's the area of the base? It's a circle, so pi r squared h. Notice again, I'm always writing down the formula first and then filling in the answer underneath. So 1/3 pi r CF. Do I know what CF is? Yes, I do. It says it right there, 5 squared. Now I have to find the height. Remember, the height is perpendicular to the base. So that right there is the height. This is the base. That's the height. So I have to find that answer. Well, what do they tell me? AC is 14. That's the hypotenuse of that right triangle. Measure of angle BCA. That right there is 6 degrees. That means this is 30 degrees. So we have a 30, 60, 90 special right triangle. We know the 30-degree side is always half of the hypotenuse. So that makes that 7, and the 6-degree side is root 3 times longer, 7 root 3. So my height is 7 root 3. Okay, now I'm going to multiply all that together and round to the nearest hundredth. Okay, so I'm going to just put in the pi last. Okay, let's see. Okay, it's right there. Oops. What just happened? I just lose. Oh, no, there's my calculator. Okay, let's see. Can I get it? I guess not. 1/3, 25, 1 divided by 3 times 25 times 7 root 3. Let's see, times, oops, times pi. Let's make sure I typed it all in right before I hit enter. Right here. 1/3 of 25 to 7 root 3 times pi. Yes, I did. Okay, and I hit enter. 317.41, because we're going to the nearest hundredth, I think it said. 317.41 cubic inch units, because volume, so it's cube. 317.41. Let's make sure I said that. 317.41, yes. Okay, so there's my answer. So this is what I'd expect to see. Writing down the formula, filling it in right underneath there so I can see if you filled in something incorrectly so it's easy to find your mistake. And that will do it at 42 minutes for mod 3.